Lesson 28, the normal probability distribution. The normal probability distribution calculates the probability associated with a continuous random variable x that exhibits a particular bell-shaped distribution called the Gaussian distribution. Even in cases where the random variable does not precisely follow the Gaussian distribution, the normal probability distribution can be used to approximate probabilities of random variables that reasonably resemble a bell-shaped distribution. The normal random variable x is continuous. As such, it can take on any value over a certain interval. In theory, the value of x can result in an infinite number of digits. In reality, the value of x is restricted or rounded, either due to practical considerations or limitations in measurement. For instance, if a person's height was measured as 6 feet tall, chances are that person is not exactly 6 feet tall. For that person to be exactly 6 feet tall, their height must equal 6.00000000 and so on feet exactly. It is not possible to measure this result to this degree of accuracy due to limitations and restrictions in the measurement process. Thus, the probability that a normal random variable x exactly equals a specific value is essentially zero. That is, the probability that the x equals a particular value of x is so small it basically rounds off to zero. Consequently, probabilities involving the normal probability distribution are calculated over intervals, that is, for a range of values from some lower limit up to an upper limit. The probability that a normal random variable x takes on any value within the interval from some lower limit L to some upper limit U is given by the following formula. Fortunately for us, this formula is programmed into the TI-84 calculator. The normal CDF command calculates the probability that on a normal bell-shaped distribution that the random variable x takes on some value from L, the lower limit, up to a value of U, an upper limit, and all values in between. So the normal CDF command on the TI-84 calculator requires the input of 4 different values. The first 2 values are the L and the U. That is, the range from the L, the lower limit, up to U, the upper limit, which defines the part of the bell-shaped curve for which we're calculating the probability. The last 2 numbers are mu sub x, the mean of the normal distribution, and sigma sub x, the standard deviation of the normal distribution. For instance, the heights of adult males are normally distributed with a mean of 69.42 inches and a standard deviation of 3.15 inches. Find the probability that a randomly selected adult male will be between 60 inches and 72 inches tall. That is, somewhere between 5 feet and 6 feet tall. Well, here the problem states that heights of adult males are normally distributed. Thus, we know that it follows the normal probability distribution. To completely describe the normal probability distribution, we need to know 2 values, mu sub x, the mean, and sigma sub x, the standard deviation. The problem states that they have a mean of 69.42 inches. Thus, mu sub x equals 69.42. And it states that there's a standard deviation of 3.15 inches. Thus, sigma sub x equals 3.15. Now, we can calculate the probability. In order to find the probability that it's between 60 inches and 72 inches, we're looking at 60 at the lower limit, up to 72 inches in the upper limit. Using the normal CDF command to do this, we need to input the 4 values. The first 2 values represent the L and the U, the lower limit value, which was the 60 inches, comma, and the U, the upper limit value, which was 72 inches. So this is going to find the probability that a randomly selected male is somewhere between 60 and 72 inches tall. The last 2 values input into the normal CDF command are the mean and the standard deviation. So here mu was the 69.42, comma, and sigma, standard deviation, was 3.15. The normal CDF command on the TI-84 calculator is found in the distribution menu. To get there, we press second, distr, arrow down to the normal CDF command, press enter to select, and then we enter in the values. L was 60, comma, U was 72, comma, mu was 69.42, comma, and sigma sub x was 3.15. Close parenthesis, enter. We see that this result rounds off to about 0.792. So we have our result. Thus, the probability that a randomly selected adult male will be between 60 inches and 72 inches tall is 79.2%. The normal CDF command on the TI-84 calculator calculates the probability that a normal random variable x with mean mu and standard deviation sigma takes on any value within the interval from L to U. So when the L, U, mu, and sigma are given to the normal CDF command, the probability that x falls between L and U is calculated. The normal CDF command finds a particular normal probability when given certain values of the random variable x. That is, when given these certain values of the random variable x, the normal CDF command calculates a corresponding probability. In order to work this problem in the other direction, that is, if we were given a certain probability and we wanted to find the corresponding value of the random variable x based off a normal probability distribution, we would use the inverse norm command. The inverse norm command finds a particular value of the random variable x when given a certain normal probability. So here, if we're given a certain probability, the inverse norm command can find a corresponding value of the random variable x. The inverse norm command calculates the kth percentile, which is denoted p sub k. And the kth percentile is the particular value of the random variable x, such that k% of all the values are less than that. So here, if we know what the kth percentile is, that is, what percentage of the bell-shaped distribution is less than the particular value we seek, using the inverse norm command can find that corresponding value. There are three values that are inputted into the inverse norm command. The first value we represent as k divided by 100 is the actual percentile, the percentage that is less than. But the calculator, being a decimal machine, doesn't want the value input in percentage form. It instead would rather have it in decimal or fraction form. The last two numbers that are input into the inverse norm command is mu sub x, the mean, and sigma sub x, the standard deviation of the normal probability distribution. For instance, the heights of adult males are normally distributed with a mean of 69.42 inches and a standard deviation of 3.15 inches. Find the 75th percentile for the heights of adult males. Well, here we're told that heights of adult males are normally distributed. As such, we know that they follow the normal or bell-shaped distribution. In order to completely describe the normal distribution, we need to know the value of the two variables, mu sub x and sigma sub x. Well, here, mu sub x, the mean, is given to us. The mean is 69.42 inches. Thus, mu sub x equals 69.42. We're also given the standard deviation. The standard deviation was 3.15 inches. Thus, sigma sub x equals 3.15. Now, we could find the 75th percentile. The 75th percentile is the particular value of the random variable x, such that 75% of the entire normal distribution is less than that. To work from the percentile to the number, we use the inverse norm command. The inverse norm command requires the input of three values. The first value is the percentile, that is the percentage of the bell-shaped distribution that is less than the value that we seek. So the 75th percentile has 75% of the normal distribution less than it. So we enter in the value of 75, divide by 100, because the calculator is a decimal machine, and just leaving it as 75% would give us an error. Or instead of entering in 75 divided by 100, we could enter the decimal version of 75%, which is 0.75. Either way, we would get the correct answer we seek. Comma, the last two numbers that are entered are the mean mu sub x and the standard deviation sigma sub x. Here, mu sub x was 69.42, comma, and sigma sub x, the standard deviation, was 3.15. So now we can enter these values in the inverse norm command on the TI-84 calculator to find the 75th percentile. The inverse norm command is found in the distribution menu. We get there by pressing second, DISTR, arrow down till we find inverse norm, press enter to select. Then we would enter in the 75, divide by 100, comma, 69.42, comma, 3.15, close parenthesis, enter. And we have our result. It rounds off to 71.5. Now the result we get from the inverse norm command is a value of the random variable x corresponding to this particular probability, in this case the 75th percentile. The units that we get from this result are the units of the random variable x. And in this problem, everything was measured in inches. So the result from the inverse norm command, 71.5, is the number of inches. So, the 75th percentile for the heights of adult males is 71.5 inches. In statistics, the normal probability distribution is relied on considerably to both determine precisely and approximately probabilities of random variables that display a bell-shaped distribution. The normal probability distribution also provides the basis for several important statistical analysis procedures, of which we'll be learning several in upcoming lessons.